going on, everybody? Welcome to What It Played, the channel we talk about all kinds of things like how to fix things, build things, maintain things, as well as product review. And today we're going to do the review on the evolution on the Jerry. So let's get into this. Alright, so as you probably seen, I do have a video out where I took this motor apart, dissected it, showed the insides, the outsides, measurements, and everything else, and how it does on a free spinning as well as on a Loadmaster. So the numbers came out really good, very promising for this motor. So we're now going to put it on the Jerry, run it through a bunch of different loads to see if it holds up to what it looks like on paper. Because as we know, RPM means nothing if it can't spin a load. So let's get into this and learn something. Alright, what I got set up here is the hobby wing tunalizer here. I have the Jerry. I have the SpeedZone right here is the drive motor, and the load motor is the Surpass V6, the fat boy. And then I have the new RPM meter. This right here again is a prototype. What's cool about this is I can also hook this up via Wi-Fi to my cell phone, so I can also get the reading on my cell phone of the RPMs, which is better for bigger numbers. But what WMH Racing is also working on when they get finished with this is this will also have a graph that will show up on your phone, so you can see the how the acceleration and stuff like that is with the motor. So let's go ahead and run this thing. We're going to do an auto test. If you saw my my previous video where I did the review on it, you'll see what the numbers were without a load on it. So let's go ahead and hit it. It's 10.67 amps. That's pretty low. And 2896 kV, 52.5 degrees. Whoops. I didn't show the other numbers, but it doesn't matter because this is just a load test, the Jerry test. Let's go ahead and do the RPM. Actually supposed to do the RPM for 20 seconds. Forgot to set up my timer. Where is my timer? Whoop, there it is. Okay. Okay, we're gonna run a timer for 20 seconds. And ready, set, go. Okay, now let's go ahead and hook on the 28 tooth. This here, if you're wondering, was the 27 tooth. So, alright, time for the 28. Alright, that was the 27 tooth. Now we're on the 28 tooth. And just so you know, the temperature from last run was 98 degrees. I forgot to put on the camera, but I checked it anyways after I turned the camera off. But 98 degrees. Now we're going to go the 28 tooth auto run. There you have right there. 10.65 amps, 2099 kV. And let's go ahead and do the, well, in case you want to see this here, numbers there still look really good. 0.5, 2.2, 2.3. 99 degrees on the end bell there. Okay, Just go ahead now and do the RPM for 20 seconds. Here we go. Check the temperature on that. Trying to see if I get a different reading from here versus there. In 103 degrees. Alright, let's go to the 29 tooth. Alright, I have the 29 tooth on there now. It's going to run auto mode. Whoop. Okay, 11.19 amps. See that there? What am I calling on here? There you go. That there. The amp draw on this thing is pretty low. Let's go ahead and do the RPM. 20-second burst. We're in the temp right now is 104. Let's go ahead and ready, set, go. Alright, time for the 30 tooth. Alright, now we're on the 30 tooth. Let's go ahead and do an auto run. There you have there, 1157 is the amps. Temperature run out is 108. Let's see how that compares to what I'm testing right here in the end bell. On the end bell, looks like I'm testing 105, so it's about 3 degrees difference. Test the front, getting a 106. See what the can is reading. The can is also reading a 106. So, what I read off the end bell is not much different than what the can is. So I know some people were saying that when I tested the R1, they're saying it's the reason why I was getting such a high temperature reading was I was taking it off the side of the can. Well, previously I tested the can and the end bell and they had the same reading. So not the can, the actual stator outside stator. So let's go ahead and run the RPMs for 30 seconds. Ready, set, go. Reading I get off that is 111. So now we're going up to 31 tooth. Alright, 31 tooth in. Let's go ahead and hit the auto. Alright, 1192, 52.4 degrees, 2057 kV. Temperature 109. Let's go ahead and hit the RPM. And let's go. Okay, temperature reading on that is 113. Now for 32 tooth, and then after that we have the 41 tooth. Almost there, guys. 32 tooth on deck. Auto run. $12.39 the amperage, 2840 is the kV, 113 degrees on the temperature there. Let's do the RPM test now. Alright, here we go. After I hit the... Alright, temperature 215 degrees. Now for the big boy, the 41 tooth. Okay, last run, 41 tooth. Let's go ahead and hit it. 1563 amps, 2717 kV. Temperature is 115 degrees. Let's go ahead and run the RPM on this one here. Ready, set, go. I went a little lower on that one, like 5 seconds farther. Okay, we have 119 degrees. Got a little warm, of course I went 5 seconds over, so probably a couple degrees, but I won't punish you for that. Alright, so let's go ahead and put the numbers on the spreadsheet and take a look and see how this thing compares. When we're going to get to the good part, here it is. Here's the good part, the SpeedZone Evolution 17.5. Had a big amp drop with the as soon as we put a load on it. 27 tooth. We had a 5.29 amp drop on it. So the speed on it looks pretty good. It looks pretty high. The temperatures stayed pretty low, but then near the end it started getting a little higher. But right in this area, the temperature didn't seem to rise much. As you can see here, the RPM increase has been pretty steady. Amp draw was a little here and there, bounced around a bit. This was a big doozy right here. Is it had a 30 amp drop, or a 30 amp gain, I should say. But it dropped 35 kV, and that's with the 30 tooth. So how does it compare to the other ones? Well, let's compare it to the R1 Works. Here you go, the R1 Works. This right here is a very fast motor. The only problem with the R1 Works is look at those temperatures. I mean, those are high temperatures. A lot of people set their motors to the temperature of the car. So a lot of people like to set their temperatures in the neighborhood about 150 to 160 degrees. Some go up to as much as 180, 190. That's thermal right there, if you ask me. But anyways, if you go by speed, the R1 Works is a faster motor. Right here, 28,000 RPMs at 15.4 amps. This is 27. You know, it's a couple hundred RPMs off for the Evolution. But if you go with amp draw and stuff like that, I mean, the R1 Works is going to be higher. It's going to be a faster motor. But if you go off temperature, I mean, by the temp gains here, looking like 4 degrees on each tooth size. I mean, you can slap at least another 2 teeth on the SpeedZone and be under or at about the same as the R1 Works. So, I mean, that's something to take in consideration there, because it's 11 degree temperature. Now, some people say, I had some people complain that it's because I took the temperature off the can of the R1 Works. Well, off video, I actually did a test of it, and it's the same. The temperature is the same. But even still, you're not going to get a 10-degree difference between the taking the temperature off the stator versus the end bell. It's just not going to happen. I have no motor out there I've ever tested has ever been different. The most I've ever had difference was like 3 or 4, maybe 5 degrees, I think, or something like that. But never 10. Anyways, how does it compare to how does the SpeedZone compare to the other ones? Let's take a look. We have the Factory Select Reds Racing. It's faster than the Reds Racing. Reds Racing had a lower temp, lower amp draw. So the Reds Racing it has more torque than the SpeedZone, is what it's showing here. But the SpeedZone is about 100 RPMs faster. Again, if you're going off amp draw versus temperature, I mean, the Reds Racing is going to be a faster one at the end because of the less amp draw, but it's so stinking close. I wouldn't even look at that, because you're not going to judge a temperature off of 5 degrees. You're going to basically look at how it's pulling, how your car is pulling, and the torque and stuff like that you're going to need. So SpeedZone compared to the let's see, 27 1563. If you go to the Hobby Wing, 22 828 and 1239. Let's see here. Here we go. You have the Hobby Wing it's running hotter. The SpeedZone was 1 degree less. So again, you know, that's nothing to look at. But the SpeedZone had 12.5 amp draw versus the 13.4. And then it also, however, the Hobby Wing is 1,000 RPMs faster. But again, you're looking at an amp, at a 1 amp difference. It's 1339 versus 1239. So it's a 1 amp difference with 1,000 RPM difference. So the SpeedZone, you re-gear it, I mean, you'll definitely get up there faster than the to where you match amperage. You'll be up there past the Hobby Wing. Plus, again, sorry if I'm making you dizzy doing this, but 116 degrees, 115 degrees, 1 degree, and this thing, when you go up a tooth, it looks like you only gain about 4 degrees in temperature going up each tooth. So anyhow, it all depends on how you judge. If you go by heat or if you go by amp draw, whatever, that's the whole thing. So let you look at, I'll go to the top. You can take a screenshot of this. You guys probably already have screenshots to save to your phones, but there's a screenshot there. And you can take another screenshot of this right here. There you go. Take a screenshot of that. And you get the full Trinity on there. Take a screenshot of that. Another screenshot. And then the final screenshot. There you go. So my final thoughts on this motor. The SpeedZone motor, it's also the lightest motor that I've tested. It's about a ½ ounce lighter than all the other motors that I've tested. It's a like a ½ millimeter shorter for the stator, and the diameter of it is about a ½ millimeter narrow in diameter. If you look back on the review that I did, you'll see the weight differences and the size difference. So it's about a ½ ounce total lighter than all the other motors I've tested. So the SpeedZone, if I was looking for something for on-road, I would use a SpeedZone without a doubt. I think it'd be an excellent motor for on-road, especially if you're looking for like 1/12 scale, where you're looking for making your car light as possible. I mean, this thing right here will get you up and going. So anyhow, there you have it, the SpeedZone. Again, it's a new model, new brand that I haven't heard before until I was on the Roar Racing site and saw that they're certified. So yeah, SpeedZone, excellent motor, great for I would definitely use it for on-road racing. If you like this video, if you learned something, please hit the like and subscribe so you can see my new other videos that are coming out. I have more motors lined up right now. I have another one sitting on my desk right now waiting for me to do a review on. It's the Orca. So yeah, if you like my videos, please hit the like and subscribe. If you don't like my videos, hit the like and subscribe anyway so you can make fun of all my other videos. All right, everybody, you take care.